Okay, so it's all about different kinds of asymptotes, vertical asymptotes, horizontal asymptotes, and writing equations for things that have horizontal and vertical asymptotes. So just to understand what a vertical asymptote or horizontal asymptote means, this little line that runs right through here, is that a horizontal or a vertical one? That's horizontal asymptote. Horizontal runs across like the horizon. Okay, so when I drew this dotted line like the horizon, that was a horizontal asymptote. And that is the number one mistake that kids make on these, is confusing horizontal and vertical asymptotes. All right, now I'm going to put in the vertical asymptote. I'm going to put it in red. That is a vertical asymptote. Okay, so there's two kinds, horizontal and vertical. And horizontal are like the horizon. If you're looking at a beautiful picture of the desert or whatever, it's the line that runs across this way as a horizontal. Okay, so now you get, if you move it up a little bit, the horizontal is like there now. Okay, is there still a vertical in there? Yeah, there's a vertical too. The vertical on this one's moved over a little bit, so it's like that. Okay, the horizontal on this one, really weird because it's just got so many things going on here. But that one's actually got two verticals, one running here and one running there. So you can have multiple vertical and horizontal asymptotes. And for all of these we are looking to describe there, well, right now we're learning about horizontal asymptotes. Okay? The horizontal asymptotes. All right. So if you graphed 1 over x, it looks like this. That is the simplest of them all. Okay, and that's got a horizontal asymptote right there. Okay, and it also has a vertical asymptote. The vertical asymptote is this one. Now, if you're looking at this graph, it's very hard to tell then what tells you the asymptotes. Okay, the vertical asymptotes are from the bottom. If you can connect the vertical to the denominator, that would be awesome. Here's another thing that vertical goes with that you need to get into your head and somehow burn into your memory. Vertical is like zertical. X-E-R-T-I-C-A-L. Because when I ask for the vertical asymptotes, you're going to be like, oh, do we do the x equals thing or the y equals thing? Okay, and it's so easy to get confused. Vertical is zertical. So if I ask you the vertical asymptotes, if you remember that the vertical are the zertical, then that means this is like an x, and that means you're giving me an x asymptote. X equals whatever. Okay? The horizontal asymptotes, of course, are the not x, but they're the y's. The horizontal and horizontal again are like these. They go like the horizon. And they are, I'd like you to try to remember this dumb word, horizontal asymptotes. It's been working in pre-calc for many years for kids. The horizontal are the y equals things. So in this case, y equals 0. It's the thing that goes across like this. So the horizontal asymptote on this one was y equals 0. The zertical, I know I'm misspelling them on purpose just to kind of annoy your brain, and then hopefully you'll remember that this is an x equals thing. It was also at x equals 0. And I hope you know that vertical is like a vertical leap. It's up and down. So vertical would be like this one. And I know you're thinking, but that's the y-axis. Yeah, the y-axis is at x equals 0. That's what the y-axis is. It's x equals 0. Okay, so if you look at this one, this reminds me of something. It reminds me that if you can factor something, you should. And the top part, I can't factor that. And you probably don't know how to factor that either. But I can factor the bottom part. What does the bottom part factor into? What comes out of the bottom part? An x. And then what's left? X squared plus 3. Now, look at this for a second and tell me, can you ever make that equal 0? Only if you could make x squared equal to -3. Can you make something squared equal to a negative? No, you can't. Therefore, you could never make that part equal 0. But you could make that part equal 0. So how could you make this bottom part equal 0 with only one thing? If x were to equal what? 0. So x equals 0 is the important spot on this one. X equals 0 is the asymptote for the, let's see, it's an x equals thing, and that's a vertical, and therefore a vertical asymptote. All right. Now let's talk about the horizontal asymptotes and how you can find them. Ooh, this is weird. This one's got a slant asymptote. We're not going to get into slant asymptotes for, you know, you're not going to be required to find them. But all right. Find the horizontals. This is the critical part. Bigger on bottom, bigger on top, or same on both. Bigger on the bottom, bigger on the top, or bigger, or no, it can't be bigger on both. Same on both. Now, this part is the horizontals. Remember, the rules for the verticals are totally different. The horizontal asymptotes, those are the ones where on the graph kind of look like this, okay? Where that's going to be is based on your equation and whether it's bigger on the top, bigger on the bottom, or the same on both. So how do you decide what's bigger? Well, here's a classic example to see if you know. Is the top bigger or is the bottom bigger? And how do you judge bigness? With the degree. What degree is the top of this thing that I just wrote? Degree is 1. Because it's got a little 1 right there. What degree is the bottom one? Also 1. So even though you're tempted to say the bottom one's bigger, it's not. It's a bigger degree on the bottom? No, it's the same degree on the bottom. It's the same on both. All right, so this would be an example of same on both. Same degree on the top and the bottom. So that's this category. So that means this is what I have for my asymptotes. The asymptote for this graph right here would be a ratio of the leading coefficients. We usually use the word ratio in pre-calc. So ratio and fraction are kind of the same thing, but ratio of the lead coefficients. All right, so what is the lead coefficient? Geez, it's a good thing we learned those just the other day. The lead coefficient on this is 1, and the lead coefficient on this one is 1. So it's a ratio of 1 over 1. So it's y equals 1 over 1, which means y equals 1. So that means this graph right here would have an asymptote at y equals 1. So this line that's running through right here, that would be at y equals 1. There'd be a 1 right there. That's the first notch. There's 2, there's 3. The asymptote line would be at y equals 1. All right, so let's see if you caught that. We need a little bit more practice on that horizontal asymptote thing. So let's say I had this, x squared plus 3x plus 1 over x to the 5th plus 4x minus 5. All right, so tell me, is it bigger on bottom, bigger on top, or same on both? It's bigger on the bottom because it's got a bigger degree. So the horizontal asymptotes, which are really the horizontal asymptotes, remember they're y equals things. This is either bigger on bottom, bigger on top, or same on both. And if it's a bob, it's y equals 0. If it's a sob, it's the same on both, so it's y equals a ratio. And if it's a, what's the last option, bigger on top, there are no asymptotes, no bots. Kind of like robots, no bots. All right, so if it's a bigger on top, there won't be any asymptotes, none, no asymptotes. All right, which one's this one again? This one's a bigger on the bottom, so therefore it's right here. Therefore it's y equals 0. So my asymptote is at y equals 0. So if I graph this thing, the asymptote would be at y equals 0, which is like the x-axis. That one make sense? going to give you a few more. Let's not use the y equals thing. Let's just say x to the fourth plus 3x plus 2 over x plus 3. There we go. What's the degree of the top? 4. What's the degree of the bottom? 1. So therefore, it's a bigger on top. What's the rule for bots again? None. There's no asymptotes. If you graph this thing, would not have an asymptote. Okay. Now I'm going to change it. Cheat. There. Now what is it? Bigger on the bottom. It's a bob. It's a degree 5 on the bottom. Because if you multiplied it out, its biggest term would have an x to the 5th in it. Okay, so what does that mean if it's a bot? No, wait, that's not a bot. It's a bigger on the bottom. It's a bob. It's a rule for bobs. Y equals 0. So if you had a graph, there'd be an asymptote at y equals 0. Now, one thing can change that. Do you get if I like put plus 5 out here, that it would move the whole graph up 5? Does that make sense? Does the asymptote move up 5 too? So Bob is really not just a 0. He is an outsider. See what's on the outside? Isn't The Outsider a classic English book? Do you guys still read The Outsider? You read it back in the day. Is that like a middle school book? Okay. All right, so y equals 0 is how you start all of the bobs. But if there's anything on the outside, you got to include that. So this one will be moved up 5 then. So I'm going to pause for a second. Okay, so this one now needs to move up to y equals 5 because I added that plus 5 on the outside. All right, I'm going to give you another one. Let's say I had this x plus 4, x minus 3, all over x squared plus 4x plus 4. Is it bigger on the bottom or bigger on the top or same on both? Same? Wait a minute, there's a 2 on the top. No, I'm 2 on the bottom. A degree 2 on the bottom. Isn't this degree 1? It's what happens when you multiply them out. Very good. So if I multiplied that all out, there'd be an x squared in it, and therefore it would be the same on both. What's the rule for SOBs? Ratio of the lead coefficients. What's the lead coefficient on this one? Well, again, I need to know. If I multiplied it all the way out, there'd be a 1 there and a 1 there, and that times that would give me a 1x squared. So it's a 1, and this one's lead coefficient is a 1, so it'd be y equals a ratio of the lead coefficients, 1 over 1, so y equals 1. That means, again, that we are having an asymptote right there at y equals 1. Okay, one more. That has a horizontal asymptote somewhere. Would you tell me where it is? And turn it my way, I'll tell you if you're right or not. Yep, yep. 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 Need the letter. Yep. 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 Oh, you need a Y. All right. Yep. 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 Okay, good. So it's y equals 3, but why? I know a lot of you, when you see somebody else got it right, you want to like look at their iPad and go, okay, what is the answer? And then you see the 3, and hopefully you like think it through then and say, okay, well, why is it 3? I'd really rather not have you look at their iPads at all, but I know it's very tempting to see what was the right answer. Anyway, so back to horizontal asymptotes are told to you by Bob. And I think of it that way, Bob. Because it's not always a Bob, but it's going to get you in the right category. So the Bob, SOB, and BOT are the 3 options. This one is same on both. Even though it's got this 3 in front, that's irrelevant because the lead coefficient, when I multiplied it all the way out, would be 3x squared, and that for degree 2. I took that and multiplied them together. And then this lead coefficient would be x squared, so it is the same on both. And what's the rule for SOBs? Y equals a ratio. And therefore, it's y equals 3 over 1, which equals 3, and that's why it's y equals 3, because it was the same on both. All right, now, you got to combine all of that. That's just to find horizontal asymptotes. By the way, that will come in handy this year you know, like for this next week and on this next test. And also, we're going to use it in pre-calc all the time. We use these asymptotes all the time. Because the other thing that they do is they tell you about the range of a function. Because if you have an asymptote like this, do you get that this function cannot go from negative infinity to positive infinity on the range? Like you can't go from down here to up there without crossing that line. So it's got to have a break in it at some point. So it tells you the range of functions too. It tells you that if this is like 5 here, it tells you that this function can't go all reals on its range because it has a hiccup in it at least that makes, and asymptotes make you go like this. You can't just have like an empty spot there. All right, so that they're handy to know. So we've just talked a lot about the horizontal asymptotes. Well, let's talk about the verticals for a minute. The bottom is what it's all about. It's not about the top. I'm not going to make any lame references to being all about the base, but it is. So we have x equals -5 and x equals 6 are the two things that would crash this function. They are either going to be asymptotes or holes. Because if you think about it, if it's crashing the function, that means that the function, it's not like the entire graph disappears. It's just that the function, if it's got an asymptote here and an asymptote here, for instance, they usually look something like this. That means the graph isn't allowed to exist right here, for example, because there's an asymptote line there. So these things at -5 and 6, the way this one would be, those two spots are asymptotes. And again, if they're coming from the bottom, then they are the verticals. Okay, so I'm going to graph you one that has two vertical asymptotes at, whoa, I hate when that happens. Okay, two vertical asymptotes at -5 and +6. Here's -5, here's +6. And then sometimes what they do, they'll do all kinds of crazy things on the inside. Maybe they'll go like this on the inside. And on this one, they might go like that. And over here, that might come in and go like that. All I know for sure is it's got two vertical asymptotes. One for this and one for that. All right, so the verticals from the bottom. So let's do another one where you have to actually factor the bottom. Because remember how I was saying that if you can factor it, you should. Factor the bottom part. And then tell me what the two vertical asymptotes are at. All right, this is why we've been practicing this on that top 20 sheet over and over and over again. So hopefully you didn't just zone out on that. You knew it was x plus 8 and x minus 8. Okay, now, what are the two asymptotes? X equals -8 and x equals +8. That means if I graphed it, I'd have 2. And are these verticals? Yeah, they are. They're vertical asymptotes. They're x equals, remember vertical? If you ever get lost on whether it's a vertical or horizontal, you can go back to that. The vertical and the horizontal. All right, so x equals -8. Here's -8. And this one's at +8. Let's say that's +8. There we go. It's got two asymptote lines like that. The rest of the graph, I'm not sure what it looks like, but I know there's asymptotes right there. Ooh, let's go back for a second and talk about the horizontals. The horizontal asymptotes are the ones Bob tells you about. Is this bigger on bottom, bigger on top, or same on both? It's bigger on the bottom. It's got a 2 down there versus a 1 up there, so it's a Bob. So what's the deal with Bob's again? Y equals 0, so there's an asymptote line at y equals 0. So then, my graph might have looked like this. For example, there's a lot of different ways it could have been, but it has to stay outside here. Yeah, stay outside the lines. All right, that's vertical and horizontal asymptotes. And what else do you have to know? Not too much, but one more thing, and that's the holes that we talked about the other day. So let me show you one that has holes in it too. Okay, take a look at this one. I am not going to expect you to do this on the test, but the research has shown that if you see something ahead of time before the teacher actually wants to teach it to you, that when I do teach it to you, that you will understand it better. So I'm going to show you factoring by grouping. You don't know how to factor that, but I do. Well, let me see if some of you can pick it up this fast. Again, not testing you on this, so don't stress. That part can be factored, and this part can be factored. And when I factor them, this part right here factors an x squared out of both things, and I get x squared times x minus 4. And this part right here, when I factor it, a 2 comes out of both of them, and I have x minus 4. If it works out such that this and this are both the same, which they are, then that means this factors to x minus 4 and x squared plus 2. All right, I don't expect you all to understand what I just did there, but it wasn't super hard, was it? I mean, I factored this first part, and I got that. I factored this part, and I got that. And since these two are in common, I put that here, and then whatever's left over here and here, those I put here. All right, so that's how you factor the top. How many of you think you might be able to actually do that from watching that? All right, so that's like 7 of you. You don't have to know that until after break, but I wanted to give you a sneak preview. All right, so that top's factored. Now you should be able to factor the bottom. That should be like an easy peasy bottom. X plus 4, x minus 4. Now what's special about this one? Well, first thing I'd want you to do on a question like this is before you cancel anything, all I've done is factored stuff. Now I answer the domain question. Domain means everything works in this function except what? And the only things that are going to crash it are the things that make the bottom 0. So everything works, you put a big R for all reals, except x cannot be negative 4, and x cannot be positive 4. Because why? Because then the bottom crashes, or the bottom cancels. Sorry, the bottom becomes a 0. Okay, so I've got my domain done. Now that gets me a neato little list. These things that would crash my function, they're either asymptotes or something else can crash the function that we talked about on Friday. Holes. Okay? This part right here, since there's one on the top and one on the bottom and they cancel, that part creates a hole. And you got to be careful. It's not a negative 4 that did it. It's a 4 that creates the hole. That one is the hole, and that one is the asymptote. Because this part right here is the part that cancels on top and bottom. That part makes the hole. The other part that's left here, that's creating an asymptote. So this is giving you a list of things that crash my function. And then we're trying to ask you to identify why they're crashing the function. The horizontal asymptote is this guy, x equals negative 4. So there's an asymptote at x equals negative 4. Notice that's not the vertical asymptote. Sorry, I'm wrong. X equals negative 4 is down here. Sorry. I even just did it there. See what I just did? Horizontal, and I put an x equals thing in there. See how easy that is? What are the horizontal asymptotes? They're really the horizontal asymptotes. They're y equals things. And Bob is the one who tells you why. So is this bigger on bottom, bigger on top, or same on both? Bigger on top. What's the rule for bots? No bots. Okay, no asymptotes. None. There are no asymptotes that are horizontal here. There are vertical asymptotes, and that's this one. Vertical asymptote at x equals negative 4. And the last thing is the hole. The hole is the thing that makes that neato canceling on top and bottom happen, and that's at x equals positive 4. But we want you to go one more step and say, okay, it's x equals positive 4, but then what's the y of the whole? Now to do that, we need to write the resulting function. After this part cancels here, what I have left is x squared plus 2 over x plus 4. There's my function. And if I know that x is 4, I can stick that into this function now, put a 4 here and a 4 there, and I will get 4 squared is 16 plus 2 over 4 plus 4, which makes, just a second here, let me get these out of here. 16 plus 2 is 18 over 8. And that's the other part of the whole. I would say that that is the hardest part right there, just because it's the hardest part to remember. All I did was stick 4 into the function. That's all I did. If I stuck 4 into the original function, it would have crashed. That's the point of a whole. So you can't stick it into the original function. If I stuck 4 into this, it would crash because of the denominator. It would make a 16 minus 16, which makes 0. But the point of a whole is it crashes. We want to know where the whole would be. So we put the 4 into this function. All right. Yes? Oh, I just didn't notice 18/8 reduces. Good point. What is 18/8? 9 over 4. I like it. That is the small stuff. And I would have had to, on a test, had to take off 5% off my grade there. Oops. All right. I know I covered a lot of stuff in 28 minutes there. And that's a lot. That's like a pre-calc type lesson. Okay, that's what pre-calc's like every day. Significantly harder class than this class. You'll get there and you'll be fine. But it's harder. All right, let's do another one. If you can factor, you should. And you can factor. That's the first thing you should do, is factor it. Then figure out your domain. All reals except x cannot be this and x cannot be that. Then the horizontal, Bob tells you why. The verticals, it's all about the base. And the whole, that's one of those things that would crash your function. Is probably going to be a whole. I'll pause for a second while you give this a try. Okay, so here's how it should have gone. You should have factored it, and you should have said 3x plus 3. And on the bottom, you should have said x plus 3 and x minus 5. Did I do that right? No. What should I have done? X minus 3 and plus 5. Ooh, that's kind of important. All right, how do I know? Because the outside and the inside mean they make a total of positive 2x. All right, now some people probably got tricked into thinking that there was a whole on this one because they thought, oh, see this and this. No, they're not exactly the same. So they do not cancel, and therefore there is not a whole. None. Okay? All right. Domain. Domain is all reals. Always start it this way. All reals. Because everything works. It's almost everything works. It's just there's a couple things that don't. What doesn't work? X cannot be 3 and x cannot be negative 5. Now those are either asymptotes or wholes. So since there's not any wholes, they must both be asymptotes. Now which kind of asymptote though? They're x equals things. Are they verticals or horizontals? Verticals. X is like vertical, zertical, remember? So they're x equals 3 and x equals negative 5. And the last one is horizontals. Horizontals are the horizontals. They're the y equals things. And Bob tells you why. Is this a Bob? Yeah, it is. It's bigger on the bottom. So therefore it's a y equals 0, unless there was something on the outside like plus 5 moving it up, but there's not. So it's just y equals 0. And there we go. Did anybody have the perfect paper? All right, 4 of them. Okay, so I knew that was going to be a hard one. At least I assumed it was going to be. But now that we've done that one, I want to do one more that I think you can get some satisfaction on, like Mick Jagger would say. And it's actually, though, you can't get no satisfaction, but anyway, I want you to get the domain, figure out the horizontal asymptotes, figure out the vertical asymptotes, and figure out the whole if there is one, and there is one. I'm going to pause for a second while you try that one, and hopefully you can get this whole thing right, especially if you compare with your partner. Okay, I'm going to pause for a second while you give that a shot. All right, there we go. We are at domain of all reals except x cannot be -3 and x cannot be 7. Raise your hand if you got that part right. Good. Next part, the horizontals. They're the horizontals. And who tells you why? That Bob. Okay, and is this an actual Bob? No, it's this one. A sob, a same on both, because when you multiplied this out, you'd have a lead coefficient of x squared. And that means that they both have a degree of 2, and actually the coefficient part is the 1 in front. So since they're same on both, it's a ratio of the lead coefficients. So y equals a ratio of 1 over 1. Y equals 1. Raise your hand if your group had that one right. Okay, good. And the next part is the vertical asymptotes. The verticals are the zerticals, the x equals things, and those come from the bottom unless there's any holes. Okay. Oh, wait a minute. Is the top factored yet? I better factor that. Let me see if there's any holes. Because if I factor it and find out that there's something that cancels on the top and the bottom, I'll then know that there's a hole. Okay. So then this is x plus 3 and x minus 3. Oh my gosh, there is a hole right there. And if the hole is going to cancel off that one, that leaves this one to be my asymptote. That one's the asymptote, and that one's the hole. Now remember, it's a vertical asymptote because it's about the base. X equals 7 is the vertical asymptote. The hole is at -3, comma, and that's, I'm telling you, the most likely place I'm going to find mistakes. If the hole is -3, the -3 is what will crash this. Then what you got to do is look at the resulting function. What's left after everything cancels is x minus 3 over x minus 7. And I take that little function and I plug the -3 into there. And I have -6 over -10. And the negatives cancel and it's 6/10, which reduces to 3/5. Did anybody have all of those parts right? Now we're up to like half the class, which is better than before. And if you know where your mistake was, we're okay. All right, I know that was a long, hard lesson, but that pretty much covers almost everything that you need to know for your next test. The last part, and this is a really easy part, is writing some equations. And this line right here, that red line, is the equation y equals 1. But do you get it has a hole in it? And the hole is at where x is 3. So, do you get that this must have had something before on the top and the bottom that got canceled? Because that's what makes a hole, right? It must have had something in there. What was in there? Excuse me. What was in there? Yes? X minus 3 would make a positive 3 crash it. Is that what we want? Yeah. You got it. That way, when this 3 goes in there, it makes that thing crash. And that means that's a hole, because there's one on the top and the bottom. So there's the equation for that graph. This one right here. That would create this graph with a hole in it at 3. All right, let's do one more like that. This one. Well, first of all, you write the equation, ignore the hole. Seriously, the best way to just ignore that hole. Act like it's not even there. What's the equation for a line that goes like that? Well, you go y equals mx plus b, and the slope here is 1. So it's 1x plus, and this y-intercept is 4. See what I did there? Just y equals mx plus b form. Now, tell me, if there is a hole here, It's at x equals 1. That tells me what canceled. What canceled? What was in those parentheses? X minus 1. That way a positive 1 would go in here and make problems for it. Okay? Now there's only one thing wrong with this. Do you see that it really needs parentheses right there? That's the most common thing I mark wrong on these when kids take the test. Because otherwise, if you don't have parentheses right there, technically you're saying 4 times this parenthesis, and it wouldn't actually cancel. If there weren't parentheses right there, this is a plus, and you wouldn't be allowed to cancel that and that. So anyway, long story, but it needs parentheses there. Okay? That way I'm allowed to cancel doink, doink, and then my resulting function is y equals x plus 4. My original function was this one. It's got the hole in it. If I want to have a hole in the function, it looks like this. If I don't want a hole in the function, it looks like that. But you're always going to want to write this kind, the kind that has the hole in it. All right. Here's one that's a little more complicated, just because the parent graph's weird. What's the parent graph in this guy again? 1 over x, good. Except we now have to include a hole. See if we can finish the deal. See where the hole is? Write me the equation for it. And then in a moment, you're going to compare it with that kid next to you. See if you got the same thing. Okay, compare it with the kid next to you. Okay, so do you get there's supposed to be a hole at x equals 3? Do you get you need a parenthesis on the top and the bottom to create the hole, right? And those have to be the same. And what do I put in them? It's always an x. And then what do I have to do to make it work for a 3 to cancel it? Like that. There's your answer. How many of you had that right? Okay, good. Told you that was the easy part. Now, let's get to your homework. I'm going to pause for a second. We'll pull that up. Okay, so here we go. It's 9.7b. And finding the horizontal asymptotes was the main new thing for today. So I don't want you to skip any of these. So do all 1, 2, and 3. Okay. These 4, 5, 6, and 7 are all the same as each other. So I'm going to have you skip 4 and 5. Just because of our time crunch today, you may skip all of 4, which is all those parts, and all of 5, which is all those parts. Just do problems 6 and 7. And then problems 8 is making an equation. I'm going to have you just do 8 and skip 9. You may skip number 9. And again, I'm going to have you skip number 11 just to try to give you a reasonably sized assignment. So would you read back to me which ones did I have you skip again? How did I start?
4, 5.
4, 5.
9.
9.
11.
11. Okay. Thank you. All right. That makes it a reasonable size assignment. Good luck. I don't expect you to be perfect. I expect you to try. And when the going gets tough, check their assignments on Schoology. And they also get going. But anyway,